In this video, we're going to talk about what I call the case of type 2 integrals. And this is the case where both m and n are even. So the first case we had, at least one of them was odd. And in this specific case, both of them are even. So let's work on an example. So let's say in the specific case, we have this. So we have sine squared of x times cosine squared of x dx. So this is where we can use this property. Whenever we have a situation like this, the best case for you to solve the problem is by using these properties. So the only thing that we are doing here is just changing from sine squared of x to this expression and from cosine squared of x to this expression. So let's do that then. So we have 1/2 1 minus cosine 2x, and then times the 1 for the cosine squared of x. So this specific case is 1/2, and then 1 plus cosine 2x dx. So now we have two constants. We can take both out. So we have 1/4, and then we have 1 minus cosine 2x, and then we have 1 plus cosine of 2x dx. If we redistribute each one, so we have 1/4, and then we have 1, and then minus cosine 2x plus cosine 2x, and then minus cosine squared of 2x dx. So we notice that both this one and this one, they have different signs and they're the same, so we can cancel those. So we have 1/4, and then 1 minus cosine squared 2x dx. So now how do we solve this one? Notice that we have 2x here, and whenever we have a situation like this, we can use this property again, in this specific case for cosine. But in this one we have x, and in this one we have 2x. So how do you solve this? The way I remember this in order to solve these problems is to just multiply it. Here's what I mean by this. You have x here and you have 2, right? And you have 2x here. So now we have, so the square is the same, but now we have 2 here. So what's going to happen is that inside, so this part is going to be 4x. So we're going to be having this expression. So 1/4, and then 1 minus, and then we're going to do the same substitution. So it's 1/2, and then 1 plus cosine, the same thing. But instead of having 2x, because in this specific case it's 2 times 1, because we have 2 here, so it's now 4. So now we have the following. So 1 minus, and then open brackets again, and then 1/2, and then 1 plus cosine, but now it's 4x dx. Okay, so now the next step is to redistribute these terms to get rid of the parentheses, and it's 1/4, and then 1 minus 1/2, and then minus 1/2 cosine of 4x dx. So just close the parentheses here. So we can separate this into further terms, and we get the following. So we get 1/4, and then dx is just 1 there, and then minus 1/8, 1 dx. Remember, this is 4, this is 2, so this is 1/8. And then we have another one, minus 1/8. I'm running out of space here. Cosine 4x dx. So we now have simple terms. We have 1 here, we have 1 here. We can solve those in a bit. But notice that here we have 4x, and we need to solve this. Okay, so let's just do that then. So we are going to just, let me get the expression here to make it clear to see. So this is what we have to work on. So we're going to use u substitution to get rid of this term and this term. So let's do that. So u is equal to 4x, du is equal to 4 dx. So when we notice this expression, we have only dx here, and the resulting term that we got from here is 4 dx. So what we need to do is to get this term out of here, and since it's multiplying on this term, it's dividing on this one. So now we can solve the expression, because now we have cosine. 4x is u, so it's cosine of u, and then dx, it's 1/4, so it comes outside because it's a constant, of du. So we can solve this one because cosine is sine, so the resulting expression here is 1/4 sine of u, and getting rid of the u and going back to the initial expression, the resulting term that we have here is 1/4 sine of 4x. This is what we have here. So now we need to take this one back, go back to the expression in order to further simplify it. So initially we had this term, so it's 1/4, and it's the integral of 1, so this is x. And then we have this term, so minus 1/8, and then it's 1, so it's x again. And we solve this term, which is minus 1/8, and the term that we got inside by the solving by the u substitution is 1/4 sine of 4x. We multiply these two, so we have 1/4 x minus 1/8 x minus 1/32 sine of 4x. We can even further simplify the expression because we have 32 here. So the minimum multiplier we have here for 4 is 8. So it's 8 divided by 32x, and then minus 4 divided by 32x minus 1 divided by 32 sine of 4x. I'll get the constant in the end. So 8 minus 4 is 4. So 4/32x minus 1/32 sine of 4x plus c. This is your final answer.